Welcome back to Electron Devices and Circuits lecture video series. In this video, we are going to discuss an application of UJT as relaxation oscillator.
After watching this video, you will be able to understand the operation of UJT as relaxation oscillator. A relaxation oscillator is considered to be one of the applications of UJT. So UJT is widely used for n number of applications. A few to point out is, it is mostly used for generating a triggering pulses for turning on the devices, another device such as SCR. SCR is silicon controlled rectifier. It is a controlled rectifier which is made of silicon. So to turn on the SCR, this UJT is used for generating the triggering pulse. And at the same time, this UJT can also be used as a sawtooth wave generators and also in other timing circuits also. And third one is, it is used as relaxation oscillator to obtain short pulse for triggering SCRs. Relaxation oscillator in the sense, without applying any input signal, the device that is generating pulses is called relaxation oscillator. So these oscillators, these circuits UJT is used for triggering some other electronic devices, mainly SCRs. Let us see how this relaxation oscillator works. So this is an UJT, you know, 3 terminals, emitter, base 2 and base 1. This base 2 is having some internal resistance and base 1 is also having internal resistance. We have discussed in the previous video. And additionally, what we have considered here means R1 and R2. See, R1 and R2 are considered to be the biasing resistor, and RT and CT. CT is capacitance and RT is transient resistance and CT is transient capacitance. And for biasing purpose, we are applying the base voltage VBB. Right, this is not a signal, this is simply a biasing voltage. So you know the principle of operation of UJT. So UJT, initially this UJT is under reverse bias with VD potential, and at the same time the potential that is existing across the resistor R1, that is called as an intrinsic standoff voltage. That means we can say that reverse bias voltage or pinch off volt or peak point voltage VP should be equivalent to eta into VBB. This is nothing but intrinsic standoff voltage plus VB. VD is cut-in voltage of diode existing in the emitter terminal. So this voltage reverse biases the diode and it prevents the diode from turning on. These things we have discussed. So when this UJT is said to be turned on, so once when this VE emitter voltage is equal to this peak point voltage, then only this voltage can overcome the reverse bias produced by this voltage. Hence, this voltage VE is now responsible for making this UJT to turn on, because this voltage forward biases the PN junction. So this PN junction is said to be in now conduction mode. So let us see how this is happening here. So this is the biasing voltage. With the help of this biasing voltage, the current starts to flow here as well as here. Initially, the UJT is said to be in the off state. This is because the voltage across this capacitor is normally feed as the emitter voltage to turn on the UJT. Emitter voltage is nothing but once when this emitter voltage VE is equal to peak point voltage, then only this voltage can overcome the reverse bias producing by these two voltages, and it allows the UJT to get turned on. Right, so initially, so with the help of this voltage VBB, the capacitance starts charging. So capacitance, once if the capacitance charges, the voltage across the capacitors increases. And this voltage is normally feed as the emitter voltage to the emitter terminal. And once when this voltage VE across the capacitor will be equal to that of VP, then the UJT is said to be turned on. Once if the UJT is turned on, means it simply acts as a closed switch. And you observe here the output is taken on the base terminal B2 is V02 and the output taken at the base terminal B1 is V01. Got it. So once when the UJT is said to be turned on, it acts as a closed switch, and previously with the help of this biasing voltage, we can able to get the output across V02. Because UJT was not open at that time. It acts as an open switch. So open switch current will not flow. Whatever the current coming here, this will create a drop here and that voltage will be available at the terminal V01. Now when the UJT gets turned on, it can act as a closed switch, short circuit. So whatever the voltage available at B2 point, those voltage will get connected to ground. That becomes 0. Right. So once if this becomes 0, so now what happens means this capacitor starts to discharge. This is because once if it turn on the UJT act as a closed switch, it get closes and it provides the path for the circuit to get connected to ground. Now the capacitor voltage across the capacitor starts to discharges, and once when this voltage discharges, this VP starts to decrease. So as that means this is nothing but VE starts to decrease. As long as VE it will be greater than or equal to this voltage, then only it can retain the UJT in on state. Now due to the discharge of capacitor, this voltage, right, this emitter voltage starts to get discharges, and while it is discharging, this voltage decreases, emitter voltage decreases. Once if the emitter voltage is less than this voltage, now the reverse bias will be more pronounced with respect to UJT, and now the UJT is said to be turned off. Right? So UJT is said to be turned off. If it is turned off, it simply acts as an open switch. Now we can able to get the output V02 simply as that of high value with respect to VBB. Now what happens? It acts as an open switch. Whatever the current that is coming through this VBB, that again charges the capacitor. And again if the capacitor voltage available at the emitter terminal will be equal to peak point voltage, again this UJT gets turned on, and this actions continues as long as the supply is available, biasing voltage is available. So this is, if you want to get a reversed polarity of voltages available at V02, we can take the voltage at V01 also. So let us see the pulses generated by UJT. So this is the characteristics curves of UJT we have discussed in previous video. This is nothing but this region is cutoff region, this region is negative resistance region, and again this is ohmic region, and again it is increasing, and again once if it reaches the peak point, again it is reducing till valley point. So this is the time period, charging time period of capacitor. This is the charging time period of capacitor taken as T. So now we will see that what will be the voltage available at the terminal V02. What I told you, when the UJT is in off state, so the voltage available at the terminal V02 is with respect to this VBB. So we can able to get a high voltage. See here, so this is the period at which this is cutoff region. So during this cutoff region, UJT is said to be in off state. So during that period, we can able to get an high voltage at the V02 terminal. So this is V02. So till this point, this is at high, active high region, and again once if the UJT reaches peak point, it is said to be turned on. Emitter voltage equal to peak point voltage, UJT turns on and it enters into negative resistance region. While it is operating in the negative resistance region, so what happens? It is said to be closed switch. So the voltage connected through ground. So V02 voltage becomes 0. So suddenly V02 voltage becomes 0. This is because the discharging time of the capacitance is made as very less compared to that of the charging time period. Accordingly, we have chosen the values of this RT and CT. Right. So as a result, so the voltage is suddenly reduced to 0, and once if it is 0, so it starts to discharge. It discharges suddenly, and as a result, the UJT again turns off. So again turns off. This is because if it acts as a closed switch, it starts to discharge. So immediately voltage across the capacitor becomes 0 because discharging is very fast. So once if it is 0, so this emitter voltage will be very less. Now this voltage, reverse bias voltage, will be more pronounced, and the UJT is said to be in off state. So again the capacitor starts charging. How long it charges? See how long it charges. See here, till it reaches the peak point again. So during this period, till it reaches the peak point again, and the capacitor starts charging. right? So here this is the period, the capacitor against charging. So here the capacitor charges again, and once if it reaches this valley point, so valley point, the capacitor is said to be turned off, right? Turned off. So once if it turns off, V02 output will be turned off, means it acts as an open. Once if it acts as an open here, output V02 will be logic high. So that's why during this period it is retaining in logic high, right? It is retaining in logic high. So initially during this period it acts as an open switch, so output is high, and again it immediately acting as a closed switch, so output is 0, and now the capacitor gets charges, that capacitor gets during the negative resistance till valley point. So what UJT is said to be in on state only. Once if it is on state, the circuit is connecting to ground. So initially the circuit is connecting to ground. Initially it's again increasing, and again this actions continues. Right, so during this period the UJT is said to be in on state, and during this period the UJT is said to be in off state. So from peak point to valley point, UJT is said to be in on state. Once if it is an on state, the output becomes on state, output is connected to ground, so output becomes 0. The capacitor starts discharging, so output voltage is getting on increasing. So again this action continues. If you want to take an output on opposite terminal V01, so this pulse will be exactly opposite. Polarity of the pulse will get reversed. So this we call it as an sharp narrow pulse. This is sharp narrow pulse. This pulse is positive pulse, and this pulse is taken as considered to be a negative pulse. So if you want to get either positive pulse or negative pulse, that depends upon the terminal from which we are tapping the output voltage, whether we are tapping at V02 or tapping at V01, based on which the polarity of output pulse can be varied. Right, so this is the waveform that represents how the sawtooth pulse. This is nothing but a sawtooth pulse, positive sawtooth pulse and negative sawtooth pulse, how it is generated with the help of relaxation oscillator using UJT. So the next one is, this is the expression for oscillating frequency. So frequency is nothing but the time taken to complete one complete cycle is called number of cycles per second is called as an frequency. So frequency, oscillating frequency, we will see how this can be derived. So this is Vc of t. Vc of t is voltage across the capacitor, that is equivalent to, so voltage across the capacitor is nothing but valley point voltage, because the capacitor starts charging from this voltage only. So this is the base voltage, this voltage plus the charging voltage. So charging voltage, how long it is charging? Till it reaches the peak point. So peak point corresponds to what voltage? So this is the peak point voltage. So initially the capacitor is starting from valley point till it reaches the peak point. This has to get charges. So this equation becomes VV plus VBB into, this is nothing but VBB into, this is what? VBB into eta, so till the capacitor is charging. So the charging equation is given by 1 minus e power minus t divided by RT into CT. This is the exponentially charging expression for capacitor. This you might have studied in transients topic in circuit theory. So, but if again here the replacement is Vc of t is nothing but capacitor, how long the capacitor has to get charged? Till it reaches the peak voltage at the time t equal to t, capital T, because for one time period, one complete cycle. Hence the above equation can be rewritten as, this can be Vp, this is equivalent to, the same thing can be written, small t can be replaced by capital T. By substituting, now you know the value of Vp. Vp is equal to eta VBB plus Vd. Substitute here, this and this are very small, so we can neglect it, and eta is equal to VBB and VBB cancelled, so eta equal to this expression. So from this expression we can derive the value of time period t. Once if you know the time period, the oscillating frequency f naught equal to 1 by t. This is time taken for one complete cycle, and reciprocal of time period you will get frequency of oscillation. So the frequency of oscillation of a circuit depends upon the transient resistance and capacitance value that we are using in the circuit. Right, so this is the expression for oscillating frequency of the pulses generated by using the UJT. So hope you understand this, how UJT as a relaxation oscillator is generating the pulses. See you back in the next video. Thank you.